Yeah, hello guys, good morning. Okay, and in today's session, we'll talk about taint and tolerations in Kubernetes, as well as what is node selector and what is node affinity. Okay, so these three topics are which are really required for us in order to schedule our pods on the dedicated node machines. Okay, so we'll talk about these concepts for today. So if you'll see this, so this is my master. So let me try to connect to my master server. Okay, hit enter. Someone looks like someone is using this on speaker, right? Try to add headphones. Okay, so the SU iPhone, and then if I'll do kubectl get nodes, here we can see three node machines are up and running, right? So if I'll do kubectl get pods, do we have any pods? Okay, one pod is running. So let me try to delete this kubectl delete pods iPhone all. Okay, so I have deleted my pods as well, so I don't think so we have anything right now. Okay, and the default namespace what we are using is test. And last session we have made this as default, right, because of some limitations on the resource quotas on namespaces. Okay, so now we have a concept called taint and tolerations. So what do you mean by taint and tolerations in Kubernetes? Any idea? Why do we need taints and what do you mean by tolerations? Okay, so basically, so what we do is, okay, let me open paint. Okay, for example, this is node 1. Okay, and we have node 2. Okay, so we have node 1 and node 2. Two nodes cluster what we are using as of now. Okay, so whenever I'm trying to execute something, like if I'm trying to add any pod, so what was happening? Scheduler was checking which node is available, where the space is available, and it was trying to schedule our pods onto that particular node machines, right? So if suppose you want to schedule any pod onto a particular node which will satisfy that particular prerequisite, then only that pod should be scheduled on that node. Okay, so in Kubernetes, if you want to make use of node machines, for example, this node machine has a capacity of GPU systems. Okay, I mean high processing systems. Okay, and these are something related to normal machines. Okay, and this particular node machine, you want to deploy the application which will have heavy workload. Means you want to fully use this GPU system only for heavy workload applications. In this case, what you can do, that will not be possible for us to schedule. I mean, whenever we are trying to use kubectl apply, what is happening? It is automatically scheduling the pod on the pods wherever the space is available, right? I mean the scheduler. But if you want to segregate, okay, I want to run a specific pods only onto the node 1. In this case, we can configure taints to this node 1. Okay, taint is nothing but a kind of filtering process or rule, I can say. For example, if suppose we are trying to attend any interview, so what will happen? So if suppose we are trying to attend any interview, recently Harita went to one interview, right? So there, what was the prerequisite? The pass out should be 2022 and 2023, and the minimum percentage what they should acquire is 70%. Okay, in this case, the company is adding one filter to segregate candidates. Okay, those who match that requirement or those who match that rules only, they have the ability or they can only attend the interview, right? So apart from that, all the other candidates or all the other resumes will not be shortlisted, right? So what is happening? They are applying one taint over there to shortlist the users or to shortlist the candidates. So similarly, taint will be applied to any of the node machine, okay? And once if the taint is applied, if the pod, whenever we are trying to schedule a pod, if the pod matches this label or this filter or this rule, right, then only this will be scheduled. For example, I'm trying to create one pod. If it matches this taint, then it will be scheduled on the node 1. If this is not matched, then it will schedule on the other pod, sorry, other node machine, which is running in our cluster. Okay. So whenever we are trying to schedule a pod, what will happen? It will first check if there are any rules configured to the node machine. Okay, yes, there is one node, there is one rule configured to the node machine, and if the pod satisfies that rule, then only it will get scheduled. So taint generally we configure to the node machine, and tolerations is something which is related to pods. Okay, tolerations are something which are assigned to pod. Means tolerations means whether this particular rule will be fixed. Okay, whether this pod is able to handle, I mean this node is able to handle this pod or not, or this pod will able to handle that node machine or able to run on that node machine. In this case, only what will happen, the pod will get scheduled on any of the node machines. Okay, so taint, you can assume that as a filter or a rule. Okay, and the taints will be attached to the node machines, and tolerations are something which will be attached to the pod. So toleration means basically whether this pod can be able to tolerate into this particular node. Okay, if only this pod can be tolerated, then only it will be scheduled on the node 1, or else this will be scheduled on node 2. The basic use case why we generally use taint and tolerations are, if we have, I mean, within a cluster, it is not mandatory that we should have same capacity of worker nodes. So we might have smaller worker nodes with smaller capacity and higher worker nodes as well, I mean with large compute engines. So what will happen in that case, if we have any applications with needs higher capacities or lot of compute resources, right? So in that case, we will dedicated these GPU machines to that particular pods only. Okay, instead of using for all the smaller pods as well, which are not really required to be scheduled onto the GPU systems. So instead of wasting that space and memory, so what we generally do, we configure taint and tolerations. Okay. Hope this was clear. Okay, so here if you see this, taint and tolerations are advanced Kubernetes pod scheduling technique. Okay, and taints are attached to node machines, tolerations are attached to pods. If I'll talk about general terms, taint in general terms means a filter or a rule. Okay, based upon this filtering only the pods will be scheduled. Tolerations with matching taint will be scheduled on tainted node. So as I said, if we want to schedule any pod over this node, right? So this pod will be having one toleration, and this toleration will be equal to this taint. Then only this pod will be scheduled onto the tainted machine or the tainted node. Okay. For example, so here we have the use case. If we have any hardware and we want to have use the special hardware to some special ports only, in this case we can configure taints. Okay, so how to create these taints? So here we have this command, the kubectl taint nodes, and then the node name, and this can be any key value pair. Okay, so this will be my key, true will be the value, and this is something related to the effect, what kind of taint effect we want to configure. Okay, so let me copy this and try to execute. Okay, so if I'll paste this here and taint nodes, right? So What was the node names? kubectl get node. So we have node called worker01, right? So let me taint my worker01 means if any pod wants to schedule on worker01, then it should have the tolerations as well, or else that should not get scheduled. Okay, so let us see what will happen. So let me add a tent. Sorry, kubectl, or else before tainting, let me show you something. kubectl describe node and then worker01. If I'll hit enter, kubectl, and if I'll hit enter, and if I'll scroll up, here if you see this taints, as of now there is no such rule added to my node machine, right? So let us add some rule. So how to add? kubectl taint node worker01. Okay, and the key, what should be the key to that particular taint? So this will be added in terms of key value pair. So this will be my taint key, this will be the taint value, and this will be the taint effect. Okay, taint key and taint value we can configure as per our requirement. It is not mandatory that we need to use special or true. So that is up to you what keys you want to use. Okay, so in our case I'm using special equal to true colon, and then make sure you are using no schedule or anything, but make sure you are using small let me copy, hit enter. Okay, the moment I have hit enter, what happened? Node worker1 has been tainted. Now if we'll check the description, if I'll scroll up, here we can see taints special. This is the key, the value is true, and then we are trying to use no schedule as a taint effect. Okay, so what can be there? I mean, instead of no schedule, so what all different parameters what we can use? Instead of no schedule, what are the different parameters what we can use? So this is something what we can I mean, that's up to us what we want to write. Okay, so but what should be the taint effect? So there are three type of taint effects. One is no schedule, one is no executive sorry, no execute, and then one is prefer no schedule. So what do we mean by no schedule, no execute, prefer no schedule? We'll talk about that. Okay, so what happened now? So we have created one tainted worker node. Okay, now if I am trying to create first.yml, so we have first.yml, right? Okay, so this was something related to secret. So let me remove this. Let me use some basic YAML. I don't want all this stuff. Okay, so let me save this. This is my YAML file. Here we haven't mentioned anything related to the nodes, right? So if I'll select this and if I'll try to execute kubectl, apply f1f, and then first.yaml, one pod will get created. Okay, if I'll do kubectl get pods, hyphen go wide, then see this has been scheduled in worker01. We have attached our rule to taint1. Okay, so what happened now? Whenever master is trying to execute kubectl, apply f1f and then the YAML file name. So what is happening? Scheduler will check if there is any kind of rules applied to any of the worker nodes. Okay, so yes, there is one rule applied to worker01, and then it will check if there is any kind of tolerations applied to pod. So in our case, we haven't configured any tolerations here, right? So what happened? So this is not matching to our taint. Then what it will do? Scheduler will check worker02 if there is any taint applied to worker02. In our case, there is no taint applied to worker02. Then this pod will be scheduled on worker02. Okay. So if you want, let me create one more pod. Its pod name, let me change to second pod. and then bucket container. Okay, now let me try to execute kubectl apply again, and if I'll do kubectl get pods f1 wide, then see again it has been scheduled on worker 02 only. If I'll execute this 10 times, then 10 times it will be scheduled on worker 02 only. Okay, because we have added one rule to the node machine and there is no tolerations applied on the pods. Okay, so now we have seen three different effects, right? So no schedule, no execute, prefer no schedule. So what do you mean by this? No schedule means no pod will be scheduled on the node machines if the taint is not matched. Means unless and until the taint and tolerations are equal, then there, if we are using no schedule, then no pods will be scheduled on these node machines. Okay, at any cost, this will not be scheduled. Okay, and then we have something called prefer no schedule. Means prefer in the sense, in general terms, what do you mean by prefer? If suppose you have multiple options 1 and 2, so which one you will prefer, 1 or 2? It can be anything, that's up to the user choice. So here when we are using prefer no schedule, here we mean that no guarantee that pod will not be scheduled on the node. There might be chance that pod might get scheduled. So what will happen? When we use prefer no schedule, scheduler will check if there are any node machines with these tails and with these tolerations. Still there is a chance, if still there are no tolerations, then still there is a chance that it might scheduled as well. There is no such guarantee. Okay, even after applying 10, and if I'm using prefer no schedule, so what will happen? There is a chance that it might schedule on worker 01 as well. For example, worker 02 is not available for any reason. Kubectl get nodes. Okay, this worker 02 is not available in our machine. So what will happen if you are using no preferred schedule taint? So the scheduler will check if there is any taint and it will check for toleration. So there is no toleration as of now, but still there is a chance that it will schedule on worker 01 only, because there are no other worker nodes. It don't have any other option. So that's the reason we are telling that we are telling it as prefer no schedule. So it will try first not to schedule. If it is not possible, then it will schedule. Okay. Whereas for no schedule, at any cost, it will not schedule on this node machine. Okay. And then we have no execute. So what will happen? So if you use no execute, if any pods are already running on tainted nodes, then it will be delete the running codes. Means, okay, for example, if you see this kubectl get pods iphone wide. So where are our pods running? On worker 02. Okay, if I'll use no execute, if any pods are already running, means as of now on worker 02 two pods are running. So let me add one taint to worker 02. Okay, let me scroll up. Here is my command. Okay, so if I'm using no execute, this time I'm applying the rule on worker 02. So what will happen if I'm using no execute? What will happen? Basically, this will also delete the running pods. Okay, these were running previously. Okay, so if now I'm trying to apply one rule, so what will happen if we try to execute no execute? So it will also delete the existing one. So if I'll hit enter, or else, yeah, let me try to hit enter. So and then if we will see get pods -o, see no pods in test namespace. Why? This has deleted because we have used no execute option. Okay, understood. So if there are any running pods and we have applied one taint effect called no execute, then it will delete the existing one as well. Okay. So now if suppose kubectl apply f1f, still we have two different rules, okay, on two node machines, and we haven't configured any tolerations to our pod. So if I'm executing this, what will happen? See, this will be in pending status only. Why? Because one is no execute, one is no schedule. So no schedule for at any cost, it will not be able to schedule on node 01 because there is no tolerations on the pod. No execute means it will check if there are any toleration. So in our case, there is no tolerations and the taint is also not matching. So what will happen? It will not schedule. Even if I'll leave this for 2 to 3 days, still this will be in pending status only. So if you'll see the detail, kubectl describe pod and then the pod name. What is happening? See, 0 by 3 nodes are available. One node had untolerated taint. Okay, that is Kubernetes master. Two nodes had untolerated taint, special equal to true, and there is no matching tolerations. Okay, so that's the reason what will happen? It will not be able to schedule. Okay, understood. Now if you want to remove this taint, okay, see this, we have already added one taint to worker 02, right? So if you want to remove this taint, what we can do? kubectl untaint is a command, and then the node machine and the node machine name, and what was the key what we have used, and then true, and then no execute, and then just add minus, hit enter. kubectl untaint known command. Okay, let me check this command. And check. Okay, not untaint, basically taint only, but we just need to add minus. Okay, let me use this same command, just we need to add minus. Okay, hit enter. So untaint. Now if I do kubectl get pod, so what will happen? It has got one node machine and this is running on worker 0. Okay, same thing if I'm trying to configure. Okay, which one prefer? No schedule. Let me check the spelling. For no schedule, hit enter. Now again we have added one rule, but still if you see this, this is still running. Why? Because this will not delete the existing pods. This was already running before we have applied any rule. One pod was running on the node worker 02. Okay, now let me try to delete this. kubectl apply -f and then sorry, kubectl delete pod -f all. Okay, we have deleted. So now if I'm trying to create again with the same YAML, let us see what will happen. Okay, as of now, no pods are running. Okay, now if I try to execute, kubectl apply -f and then forget YAML. Okay, second pod has been created. If you see this running on worker 02. Why? Because we have used prefer no schedule, means first it has checked. Okay, I will not try to schedule, but still there is no guarantee because there were no other pods or sorry other node machines running. Okay, so what it has did scheduler, it don't have any other option, so that's the reason it has been scheduled on worker 02. Understood? So what was happening with three different effects? This is very important, guys. Taint and tolerations and node selectors and node affinity. Okay, yes or no? Okay, so now how to apply any toleration? Okay, so what we have did, how to apply the taints on our machine, on our nodes, we have seen that. Okay, now but how to apply the tolerations? Okay, so here we have one of the simplest YAML file. So let me copy. Let me try to delete this kubectl. Before deleting, let me untaint one worker node because I don't want to have two nodes as taints only. So let me untaint one. Okay, one has been untainted. So one we have our rule applied, that is worker 01. Okay, if I'll do kubectl delete pod -, all, then we have deleted all the running pods, right? So now let me modify my YAML file. So if I'll paste this, so what we are trying to use API version, kind, metadata, specification. So this is something what we have seen regularly. Okay, now if you want to add any kind of tolerations rule, then we can use tolerations and then key. What key we have used? I have used special, right? So this is something related to the taint key. So taint key was special and the operator is equal. So I will talk about this operator. Okay, and then value is true. Okay, this is the taint value, and then effect what you want to use, whether no schedule or what. So what we are doing, we are trying to add one pod, create one pod with a specific toleration. So now what will happen? This pod will get enough uh, requirement or enough capacity which needs to be run on node 01 only. I mean, there is no extra capacity adding, but it is just a rule. Okay, we are specifying. Okay, so for this node machine 1, we have this toleration, so this pod will be able to run on node 01. Okay, so now here if you see this operator is equal, if suppose we haven't specified the operator, then what will happen? It is not mandatory, but still if we are not passing this operator, what will happen? It will by default pick as equal. Okay, so we can use only two values. Operator value can be equal or exist. Okay, so let me save this. Now if I try to execute my YAML file, this time this will work on node 01. Apply, and if I'll do pods, worker 01. Why? Because there was one rule and we have configured the tolerations as well onto the pod. So that pod was able to execute on worker 01. So this is how we can add tolerations to our pod machines in order to execute some pods on some special node machines. Okay, so this is how we can schedule our pod machines onto the specific nodes. Which node you want to schedule this? That can be controlled with the help of taint and tolerations. Okay, and then we have seen this untaint, right? So untaint, no preferred schedule, no execute also we have seen. Okay, exist. So what is happening? So as I said, we can use two operators. One is equal and one is exist. So what will happen? In exist, it will check if any key with value special is there or not, and it will apply toleration. So what will happen is it will only check with the key name. If the value is special, true or false, then still, for example, okay, if you see this kubectl describe node worker 0. So what taint we have given? We have given the value as special and the key, sorry, this is our key and the value as true. Okay, so for example, if you have multiple node machines with the same taint, I mean with the same value, sorry, with the same key as special only. So in this case, what will happen? If you want to schedule on any of the node machine with the key called special, then we can use exist. So it will just check if there is any key with special key is available or not. It will not check for the value whether it is true, false, or something else. It will just check for the key. Okay, key special, we have two nodes. So out of the two nodes, it can be scheduled on any of these node machines. Okay, so in such kind of cases, we can use exist or as our operators. Okay, and then we have toleration seconds as well. I mean, into the same template, if you are using the effect as no execute, we can use toleration seconds as 60. Because what will happen? It will wait for 60 minutes and then it will terminate the pod. So earlier what happened? So let me again try to use this. Okay, let me add one taint to my node worker 2. Okay, this time special and the value I want to use is false. Okay, I'm adding one tent. The key is special and the value is false. And here I want to use no execute. Okay, before doing this, I just want to run one pod, right? So let me do one thing. Let me edit same YAML file. Okay. And then let me add toleration seconds. Let me copy this. Okay, this time what will happen? Let us see. Let me make the change, or else let me delete the existing pod, kubectl get pods, because the pod name is same in this YAML as well. Or else let me make the changes in the YAML itself. Second container and then second pod. Okay, now if I try to execute kubectl apply f1f first.yaml. Okay, now if I'll do get ports f1o wide, then this is running on node machine 2, because if you see this, what toleration rule I have added, the key should be special, so worker01 key is also special. Okay, operator should be equal means special equal to true. In our case, I have given false. So there is no sustain to worker02 and there is no sustain to worker02 as well. Okay, and here I have added the effect as no execute and then toleration seconds equal to 60. Okay, now if you see this, get pods, two pods are running, right? So now let me add one tainted rule to my worker02 and let us see what will happen. kubectl taint worker02 and this should be false because I have used as false in my YAML, and here we are using no execute. Okay, now this is been matching. So if I do pods f1o f1w, so let us wait for 60 seconds and then we can see it will get deleted. Guys, if you have any questions, then let me know. Sixty seconds, and hopefully this should get terminated. So basically, what we want to do is, if there are any pods which are running already in the worker02, this should wait for 60 seconds and then this pod should get deleted. See, if you see this 2 minute 72 seconds, right? It's a 2 minutes 6 seconds and then it has been deleted. So it waited for 60 seconds and then it had deleted all the pods. Okay, so this is how we can use no execute, no schedule, and prefer no schedule. Three different effects in taint as well as three different kind of effects in tolerations. Okay, understood? Okay, now let me remove the stains whatever we have added. So I just want to remove this. So this is one concept. Okay, and then let me execute this stent as well. So what was there? no schedule, schedule, which was configured as true and which was applied on worker 01. So let me remove these two tails. So now, as of now, we don't have any rules. kubectl delete port iPhone. I've deleted all the ports as well. Now we don't have any tails and we don't have any toleration. So we have seen these tails and tolerations. Now we have one more concept called node selector. Okay, so node selector, what will happen basically? Node selector help us to select node where the pod can be scheduled. So these are advanced scheduling options available in Kubernetes. So we can use multiple options like tail and tolerations also we can add, as well as we can use node selector as well. So what will happen? It will check for both the conditions, what condition we have used for node selector and what rule we have applied. If both the conditions satisfies, then only the pod will get scheduled on the particular node. Okay. So we have one more concept called node scheduler, and this is pretty straightforward process, guys. Node selector. So this will help us to select node where the pod can be scheduled. So we are directly mentioning here. If you see this, this is our YAML file. Here I am configuring node selector and then the label of that node. So what will happen? My pod will be scheduled on this particular node only. Okay, there is no rule, there is no tolerations required for now. Okay, so what will happen? So node selector basically help us to select node where the pod can be scheduled. It will work based on the label attached to node. So what we have seen all these days was, once again, yes. So what we have seen all these days was, we have seen labels to our pod machines, sorry, pods, but we haven't worked on labels on node machines. So we do also have labels on node machines as well. So if you want to see kubectl get nodes -, show -labels. Sorry, yes, it's not working. Why? Okay, okay. Now here, if you see this, this is the default label which is configured to my master, and this is to my worker 01, and this is to my worker 0. Okay, so this is the default label. Now I want to add my own label. So what we can do, we can use this command kubectl label nodes, because node selector will be working only on labels. It will check if the label is available, then okay. If the label is not available, then not okay. Okay, so if you see this, paste. So here the label what I am trying to attach is env equal to prod, means environment equal to prod is what I want to provide. Okay, worker 01, I am trying to add one label, and again if I'll do show labels, here we can see. Okay, here we can see env equal to prod. Okay, so we have added the label now. So now let me try to use YAML file. Okay, and if I'll try to copy this existing YAML file, same YAML file for pod, but the only thing what we have been added is node selector and then the label name which needs to be added. Okay, now let me save this. So what will happen if I'll do kubectl apply -f and then YAML file name. Okay, created. So if you'll check the list of pods, kubectl get pods -o white. So what will happen? It will schedule on worker 01 only. Why? Because of that label what we have configured. Okay. For example, let us see what will happen if the label is wrong. For example, we don't have any label with test, right? So let me make it as test, and let me change the container name as well, because it will not get scheduled, right, if the same container or pod name is available. So this one also let me share, rename to second pod, and if I'll save, this time I'm trying to create one more pod with the label where it will check for the label called test. In our case, there is no such label what we have created to our node machine. So let me see what will happen. Sorry, I need to apply. Okay, now if I'll do pods and name. Okay, if I'll do kubectl describe pod, second pod, sorry, second pod. Pod name is second pod, right? Yes. Here if you see default scheduler, there is no such kind of label available. Here it is telling as node affinity. So what is node affinity? We will be going to see in our next concept. Okay. So what is happening? It is trying to check for the label called test. If there is no such label, then this pod will not be able to schedule. Even if I'll wait for 10 days, this pod will be still in pending status only. Okay. Now kubectl get pods -o white. So we have, sorry, kubectl. Okay, this is still pending, right? So let me add one new label. Okay, to my worker02. Label as environment equal to test, and this is worker02. So what will happen now? This pod will be scheduled on worker02 because now this pod has got one node with the label called test. Okay, so this is how we can schedule our pods by using node selectors. Okay, node selector, there is no rule. We are directly telling, okay, check for this label. If there is any label available, then schedule. If there is no label, then be in the pending state only. Okay, for example, now again let me do one more thing here. Okay, so as of now we are running two pods. One is on worker01 and one is on worker02. So how this has been scheduled? This has been scheduled based upon the label name. One is prod and one is test. So now let me try to remove one of the label. Okay, so what will happen? Where is that command? Okay, so let me remove one of the label. Okay, kubectl label and which node name? So let me try to remove for worker01, and the label name is, what was the label name for worker01? pnv equal to prod minus. What happened? Error, invalid label value. What happened? Remove label to worker node. Label key. Okay, it is not asking for the value but only the label key. Okay, so in our case the label key is env. Okay, unlabeled. Now if I'll do kubectl get pods, then we can see still one pod is running. There is no case of no execute and all. Okay, so what it will do, basically, this even after if some pod is running or with the help of label and we are trying to remove that label as well, still this pod will be running only. Okay, once this is deleted, then again if we are trying to start, then it will not be able to start. Okay, if you want, we can check the labels as well. kubectl get nodes --- show -labels. Okay, here we can see the label has been removed on worker01. Okay, now if I'm trying to do kubectl get pods, two pods are running, up and running. Okay, so there is no difference even if we are trying to remove any label after a pod is scheduled. Okay, if I'm trying to schedule a pod again, this time, for example, let me again modify my first.yaml. This time let me change the pod name as third and the container as third. Okay, and the environment, let me use prod because it was related to worker01, right? So if I'm trying to execute this, so what will happen? kubectl apply -f and then first.yaml. So if you see pods, then we can see this as in pending status because there is no such pod with a label called env equal to prod. Okay, So it will always check on key value pairs. Key means env, value is prod or test what we have used. Okay, understood. So let me delete this kubectl get, sorry, delete pods f1 f1 on. I have deleted all the pods and we have only one label as of now, that is env equal to test, and the 2 on worker 02. If you can see this, okay, on worker 02 we have one label called env test. On worker 01 there is no label. Okay, so understood. Okay, now we have something else called node affinity. Okay, so basically node affinity, again, I mean, this is also used to schedule pods. Okay, so node affinity is a set of rules used by the scheduler to determine where a pod can be placed. Okay, so whenever we send any request to scheduler, right, to schedule one pod, then what will happen? Scheduler will check where this pod needs to be scheduled. Okay, and before this, it will check if there are any kind of node affinity rules are configured or not. Okay, so here we have two type of schedulings, one we called as soft scheduling and one we called as hard scheduling. Soft scheduling. Okay, so if you see this node affinities, we have two type of node affinities. One is preferred during scheduling, ignored during execution. So let me copy this. Okay, so let me copy this. Okay, preferred during scheduling, ignored during execution. So let me break down this into two different sections. Okay, so this is our first type. Okay, so in this, again, let me break this into two different parts. Okay, preferred during scheduling. So what will happen is, whenever we are asking scheduler to check if there are any values or labels is matching, then schedule pod on the node. Okay, so what was happening here, for example, vi first.yaml, so third pod, so there is no such label called prod is available. Do we have any such label here as of now? No, right? So what was happening? Our pod was not be able to schedule. It was in pending status only. So that's where we have the node affinity rules again for node selector, I can say. So what will happen? It will first check if there is any pod. Here, if you see this, preferred during scheduling means, what do you mean by preferred during scheduling? So if, as we have discussed for tails and tolerations, right? So prefer, no schedule or no execute, right? So prefer means it will first try to give the preference to that label. Okay, if there is any node with that label called prod, if there is any such node available, then the scheduler will try to schedule the pod. If there is no node, what will happen? It will deploy on the node which is available. Okay, so basically this will make sure that our pod is scheduled on the specific label node or some other nodes as well if the label is not available. Okay, see here means we are asking scheduler to check if the values or label is matching, then schedule pod on the node. If it is matching, then it will schedule. And if node with same label is available, is not available, okay, then it will schedule on any available node. Okay, so earlier what we were seeing in node selectors, it is not able to schedule, it is in pending state only. But when we add node affinity rules again, okay, and again in that, we if we are trying to add preferred during scheduling and ignore during execution, so what will happen? It will check if there is any label or not, and if there is no such nodes with that label, then it will try to schedule on any other node machine which is available. Okay, and when we talk about ignore during execution means if the pod is already scheduled on node and later on we have removed the label, then the pod will be ignored and continue running on the same node. So this is what I have shown in node selectors as well, right? So same concept, ignored during execution means once this is been running, it can be ignored. If the pod is running and the label is removed, then still it can be ignored. Okay, so how to add this node affinity rules? We have this over here, so let me copy this. Okay, so as of now we have only one label, that is env equal to test. So let me use prod as my label and let us see. Okay, so earlier what was happened, it was in the pending state, right? So here the values I will be adding as prod. Okay, so this is the same YAML file what we were using for our prod, and then we are trying to add affinity, and then again in affinity we are trying to use node affinity, and in node affinity which type of rule you want to configure. This is preferred during scheduling, ignored during execution rule. And again in this preference match expression, so it should check for the key called env, and the operator in means in, not in. We have two different type of operators, means environment equal to prod. So this should check if the environment and the value is prod, then only this should be scheduled. Not in means this can be ignored. This should not be scheduled in the node where the value is prod. Okay, and weight equal to 1. So what is this weight? So this is something related to the preferences, what we have seen rules in NACLs, right? So this will also act as same. So if you want to see more details, then what we can do, we can use kubectl explain pod --, recursive type less. Then if I scroll down, here we can see affinity. So this is from where we have copied the section. Okay, preferred during scheduling, and then this one. Okay, if you want to use the another rule required during scheduling, then we can use this part. Okay, so you will get from explain command. Okay, now let me apply kubectl apply -f and then first.yaml. So what happened, one pod is created. Now if I'll do get pods, this is in running state. Okay, kubectl get pods -go wide. Okay, so where this has been scheduled, this has been scheduled on worker 01. Why? Because on worker 01 environment equal to test. So first it has checked whether there is any environment equal to prod labels or not. So scheduler didn't find any pod. Then again it has checked. Okay, so this is something related to preferred during preferred after schedule, right? So what happened? So this was trying to, sorry, preferred during schedule. So what happened? It tried to check if there is any label with environment equal to prod. So no label was available. Then check whether any pod, any worker node is running without any labels. Then it has scheduled on that label. Okay. So earlier, what we used to see, we used to see this as in pending state. But for now, what is happening? It is first checking, and then it will trying to schedule. Okay. Similarly, we have one more rule required during scheduling. Here, if you say required means this is must and mandatory requirement. So this type of executions we called as hard scheduling. Okay, earlier what we have seen was soft scheduling, and now what we are trying to see is hard scheduling. Means it is asking scheduler to check if the value or label is matching, then schedule the pod on the node. If not matched, then the pod will not be scheduled on any other worker node. Okay, ignored during execution means same. If something was running before, then it will be ignoring that. Okay, so required means mandatory. This is required for scheduler, or else it cannot be scheduled. So let me copy this. Okay, let me modify my first.yaml. Okay, let me paste. Here I will try to use the values as prod because we don't have any node with the value with the label as prod, right? So here in values for operator can be in and not in. Okay, so values as prod, and here I am trying to change the rule required during scheduling. So here no need of any weights. Okay, so let me save. Before save, let me change the pod name as well. Okay. Third pod. Okay. Third container. Okay, now if I'm trying to execute this YAML, kubectl apply f1f first.yaml, now we can see this will not get scheduled because it was searching for the label. What is still pending? If you'll see the description, kubectl describe what? Describe pod and then pod name, right? Pod third pod. So what is happening? See, it is trying to match the node affinity, and there is no such pod with the label called prod. So what happened? It has been not able to schedule because we have used required during execution rule of node affinity. Okay. Now if I'll try to add one new label, so what will happen? That will get scheduled on this particular node machine. So for example, let me delete this running pod kubectl delete pod and then third pod. So let me delete this. So now we don't have any pod. I mean, we have only one pod as of now, which is running. So now let me make changes in my YAML. So this time what I will do, I will use not in. Means environment equal to prod should not be selected as a label. So let us see what will happen. If you have multiple labels, then we can pass this in terms of values. Okay, here if you see something related to iPhone means array list in YAML, right? So let me hit enter and let me try to apply and let me see what will happen. kubectl apply. Okay, and if I'm trying to get the pods, say running where in worker02, because this time our requirement was environment should not be prod. Apart from prod, if it is something else, then it should prefer that node. So now it has scheduled on worker02. If you see the nodes, kubectl get nodes hyphen show hyphen labels. LAPS kubectl. Okay, environment equal to test was available, and what I have given was environment should not be prod. If you see this YAML, environment should not be prod. So it has checked, okay, environment should not be prod, and this is test, so schedule. That's how node affinity rules will work. Okay, so if you want to select any specific node, we can configure node selector, we can configure the node affinities, we can configure 10 tolerations as well. So if you are configuring all these rules, so what will happen? It will check for all the three rules to be matched, and then if it is matched, then only the pod will be scheduled on a specific node machine. Okay, so we are trying to assign some rules to our nodes, and we want to have some kind of configuration to our pod. This pod needs to be executed on this particular node. Okay, this is very important, and as part of interviews as well, this will be asked. I mean, node selector, node affinities, and 10 tolerations. With this, I will try to close for today's session. Okay, so I think we are good with this. If you have any questions, then let me know, or else we can wind up. Guys, do we have any questions? Okay, let me stop this recording.